joining this session. So today we will be talking about AWS CloudFormation. Before we really jump on and understand what exactly is the CloudFormation and other stuff, let me quickly give a recap about what we have learned in the past session. So for the guys who have just joined the session for the first time, we also do understand and quickly learn about it, right? So in the last session, which was on last Saturday, we quickly learn about what exactly is serverless, why do you need serverless whenever you have like any short-lived application which can run up to a couple of minutes and it's stateless in nature and you really don't have to worry about scaling and all and pay as milliseconds. There exactly we saw that serverless makes much more sense for you guys uh, to help around. And when it comes to serverless, it's completely dependent on event-driven programming. So and then we also understood like how exactly events and all of the stuff work, like what in detail. Let me see if I can just present my slide around that. Give me 1 second. I hope you guys have got a chance to go through the GitHub repository, which was shared in the last session. Okay. So yeah, I think this is how we started the serverless session. We understood around what exactly is the serverless, a cloud native platform for short learning stateless application, runs on event driven and easily can handle the scale up, scale down. You really don't have to worry about it. And there are a couple of, you can think of benefits which you get when you adapt to serverless. Then why exactly serverless is attractive or people always talk about serverless. Then we understood like exactly it's is it no server or is it very less about server, which you guys, as you mentioned, that is very less about server and your code runs on demand on per request basis, which dynamically dramatically faster, cheaper and easier when it comes to entire development or deployment of it. And then we did a quick comparison how exactly the serverless tends in AWS ecosystem, comparing different offerings what AWS provide in terms of compute. So as we talk about on the x-axis, your concerns over implementation decreases, and on the y-axis you see that your focus is much more higher on your business logic. That means that you really have more focused on what you want to design rather than how exactly you will deploy. So that deployment overhead get minimized by adopting serverless. And then we understood like how exactly what is event source, what is function, and what exactly the action the Lambda can take. And these are the different programming language where you can develop your Lambda. We had a quick demonstration where we deploy an hello world Lambda. The same code snippet is in this repository. If you still haven't got a chance, I would request please spend some time from this weekend and try out this exercise. It will help you to understand in detail how Lambda works. And then we went down granularly on the code and we understood how exactly what are the three components or three objects required for Lambda. So which is a handler, which is nothing but this function name, event object, which invokes this Lambda, or simply way I can put it in layman language is the input. Context object is more about describing how exactly the Lambda, things like the request ID, log group, etc. Then we understood about step function. If you need an intelligent orchestration layer in AWS, then step function is a go-to service, not only just for Lambda, even for other stuff like data pipeline. If I talk about SageMaker, if I talk about step function has widely adopted in recent years across different services of AWS. Then we also understood about SQS. It's a very old service, older than even S3. And then why you need it, what are the best practices and other stuff. And then we talk about the SNS, and we understood the difference between SQS and SNS. The different ways you can invoke the Lambda, as we also understood someone asked about synchronize or synchronized pattern. What's a poll-based approach? The different way or different serverless architecture you can design a couple of them with help of SQS and SNS and S3 bucket. The different use cases, like there's a very handful of them to get some example or some understanding. Again, these are very limited. There is much more you can do. Like even you can host the machine learning inference side of things on Lambda. So just a sample of example. I would say a couple of examples, and very important slide. Like when people always do motivated to adopt Lambda, but you need to be cautious that it's all about understanding your requirement very well, and then you design something out instead of just designing it out, right? Because it doesn't make sense that always the answer is serverless. In certain cases, answers are even ECS, EKS, I mean the containerization service or offering from AWS, or even they are EC2 stack. So the answer is not always that you have to go with Lambda. You have to really understand the need and the type of your application. And then we looked a quick demo how exactly the Lambda can invoke when it comes to SQS, as well as we understood if you upload a file in S3, how we can detect automatically the content type. And that's how we wrapped the session last time. And again, as I said, please go through the GitHub repository. The link is with your faculties. Please go through that, understand, and try the hands-on, right? So with that, I'll switch back to our today's agenda. Today we'll be talking about next step. Last time we talked about serverless. Today we'll talk about CloudFormation, which is also very important service when you talk about DevOps, right? So DevOps, technically, I mean, it's a very wide, I would say, ecosystem or wide stuff it is, right? Ranging from, just give me 1 second. Sorry, I think there was some background noise. So yeah, I think when I talk about the DevOps, right, there are a couple of core pillars which we will see in next week, like how exactly DevOps and what are their core pillars, right? Majorly is you need to understand how to develop your application, then you understand how to automate your application, and then you understand how to monitor it, right? If we talk about very high level. So last session, we understood how to play around with the application or how to develop and deploy the application. Today, we will be focusing on automation. And in the next, which is the next Saturday, when we will have the next session, the last session, we will really constitute what we have learned in first two session, and we put it out into that third session, how exactly things work in real life, and whatever you learn in past two session, how those two dots will connect overall as a DevOps, right? DevOps ecosystem. So with that, let me quickly start with CloudFormation. We'll talk about why CloudFormation, what is CloudFormation, how it works, concepts, and other details, right? With again, with a proper demonstration. Uh, as a speaker, you know myself. I think this is the second session we have, so I'll quickly jump on. My name is Sanchit. I work as a lead architect at Quantify. Along with that, I'm also an AWS APN ambassador. Outside my job at Quantify, I always love to talk about new technologies, writing blogs, giving communication, I mean, contributing to communities via different speaking events and other stuff. That's what I do in my free time. You can reach out to me on LinkedIn, Twitter, or GitHub. I'm very flexible and open and can help you out if you have any other advice in terms of your careers or anything you need in terms of your cloud knowledge. With that, let me jump to today's session. So first, before we go and really understand what exactly is CloudFormation, right? Let me start with always a why, because this is very important topic. First, you need to understand why you need CloudFormation. Then it becomes very easy that you can take that why and put it out what exactly is CloudFormation. Let me give you an example, okay? You all guys are looking forward to start your career in cloud computing space, right? Everyone is very optimistic. I want to start my role as DevOps engineer, as cloud engineer. I mean, that's exactly all over the place. I mean, the buzz in the market in IT industry. But let me tell you, when you talk about DevOps and cloud engineer, you are also responsible to provide the required infrastructure to yourself, to your team. And as a part of it, let's say if I ask you that, okay, your job is just to launch 10 EC2 instance every day. You just have to do the same thing. Join the office, launch 10 EC2 instance, and those 10 EC2 instance, you have to deploy, let's say Python, you have to deploy, let's say AWS CLI, and you have to deploy Nginx. That's what you have to do in all the 10 servers every day, like all 5 days for a month, for 2 months, for 3 months. I mean, at least I'm telling you, not even a month, after a week itself, you'll start getting bored from your job. He's like, what is this? Every day I come up, I launch EC2, a couple of EC2 instance. In the evening, I'm stopping it. Next day, again, I have to come up and launch new one, and I'm stopping it, right? There you will feel like, okay, what's happening? Is there any simplified way where I can look forward? The answer can be multiple of it. You can take a copy of the current machine, you can do automation around it, right? But copy of the machine also may not work in certain extent, because it's not always a fresh image. It may be an old stale image with the old data and all, right? So answer is, you will try to use some skills or some programming skills to automate it, right? Whether you may, if you come from a, let's say, Python background, you might start writing a Python script. If someone is coming from, let's say, Java background, someone will write a JavaScript. But if I tell you that, okay, you really don't have to write even programming, we have a very simple of module approach, where you just define, this is my EC2 instance, this is my configuration, and this is what I have to launch. And you just deploy those applications with one single click. Still you will accept it, right? That, okay, yeah, I've just write it down one, and then whatever, today is 10, tomorrow is 20. Let's say after 3 months it becomes 100. I really don't have to worry. I just have to give the number, how many instances I need to launch of EC2, and it's just single click, right? You will still be okay that, okay, yeah, fine. I mean, that's okay. I can launch EC2 instance a CloudFormation stack easily. There exactly the answer comes is why. Why exactly CloudFormation is required is, CloudFormation simplify the way you deploy your entire in platform, right? Now, again, this was a very basic or simple example. I'll give you, as we move throughout the session, we'll also understand there are many such many such things required when you work day in and out as a cloud engineer, as a DevOps engineer. This is just a very simple example, right? So first, when you talk about why you use CloudFormation, right? So CloudFormation supports different resources. So technically, there are 200 plus different AWS services are there. Each services has a different configuration. Now, some configuration would have like, if I talk about Lambda itself, what we have learned, right? Now you can deploy that Lambda within VPC. You can deploy that Lambda in Python. You can deploy that Lambda in Java as a runtime, right? There are many combinations, configuration you can provide to that. So first, CloudFormation supports a larger amount of AWS services, right? Not just limited to EC2 or, let's say, any container service or VPC. It even supports things like S3, assigning static IP address to EC2 instance. So it supports variety of different resources, and which makes it very simple, very reliable and available. Two, as I said, it is very easy to use. Like, it comes with JSON and YAML format. You really don't have to worry about in detail like how exactly your CloudFormation works, right? Like, if you know that, okay, this is my JSON, I mean, it's all about representation, which you'll see in upcoming demo, but it is very simple, flexible and declarative, right? So as I said, CloudFormation, the best part of CloudFormation is the way the CloudFormation has been designed overall. It's very declarative manner, right? Now, declarative means is, now, as an individual, I might define the EC2 configuration in a very different way versus you guys will be doing, right? I might require from an enterprise perspective or any app production perspective. So I will have very complex features, whereas you guys might doing a very simple POC, then you will have a different feature. So all those things differs from the kind of way, the kind of application it is. Next is the customization through parameters. Give me 1 second, guys. Sorry. So yeah, customization through parameters. Now, the best part of CloudFormation is, as I said, now today you want to launch 10 EC2 instance. Tomorrow you want to launch, let's say, 100 EC2 instance. So if you see that, right, as we grow, the scale also grows sometime of the application. Now, today, when you're starting working on application, you will start with very simple. When you start over a period, let's say 3 months, 6 months, a year, the scale and the volume of your platform will increase. So you need to ensure that you can customize it through parameters, through different environments, right? Now, when you I mean, in next session we'll also see that what are different environments you have, but I think you will be, at least as of today, you will understand there is something called as production, there is something called as development, right? Now, CloudFormation, you can't have like a different script for development, different script for production. It's like your code snippet, right? Your Python script, that you have Python script for sure what you're running or developing in dev environment, you will take the same thing in production. That's how it works. Like, okay, CloudFormation also works in a similar fashion, that you customize it through parameters to ensure that it works across different environments. And last, it also simplifies over and above. So many people always think, right? I mean, when I'm giving or talking about CloudFormation, many people always think CloudFormation is a tool for programmers. because it, as the name suggests, more cloud infrastructure as a code, right? Whatever the infrastructure you have, you put it in a form of a code, because all those features, flexible, declarative, you can customize through parameters, all are the sign of the coding language, right? How do you code a programming language? So many times people do tell me that, okay, no, CloudFormation is for my development team, not for me. There exactly, AWS has come up with a designer tool, like how you can design your architectures and all. Similarly, you can design your CloudFormation from the UI itself, which makes it more flexible, adaptable across larger audience. We'll also see, if we get a time today, we'll see how exact that UI look like, and it's very simple. So that's how, why you use CloudFormation, because it supports different resources, easy to use, flexible and declarative. You can customize through parameter, and at the last, it provides a very simple approach of drag and drop UI based. Now we understood in detail, right? So it is very easy to map that why in form of CloudFormation. Like, what exactly is CloudFormation? So far, I think everyone on this call would have understand that CloudFormation provides a simpler way or an automated way to deploy your infrastructure. And the same example. Now, in reality, when you're working in any industry or working in any, let's say, bigger project, right? You're not just responsible for deploying one EC2 instance. If you talk about the example which I gave in the beginning, we were only talking about you have one EC2, you have to install Python in it, you have to install, let's say, AWS CLI and Nginx. In ground reality, it's not the case. I mean, I'll give you one example. Any small application, even if I'm building a serverless application, serverless data pipeline or serverless application, bare minimum, there are 10 services. At minimum, there are 10 services which goes into that particular serverless pipeline, right? Starting from things like you have S3 bucket, things like you have SNS SQS, things like IAM roles. Those are the small things also you need. And those small things becomes a big problem of failure, because what happens when you try, go and manually deploy, right? It's all over the place. First, you might be, you make mistakes, right? That, okay, you didn't give a right configuration. Let's say you didn't give a right memory to Lambda, or we also understood how you have to provide the runtime, right? Like the timeout in the Lambda, what we understand. Some people tend to forget, like how to increase that stuff, right? So those are the different things that comes up when you do it manually, right? There exactly, CloudFormation not only help you to make it more repeatable, but also help you to get out of remembering anything instead of coding everything, right? You code whatever is required, right? From increasing the memory of Lambda, right? From increasing the timeout. Let's say you need Python, Java, whatever, you code everything within CloudFormation, and then you deploy the CloudFormation. So this way, today, let's say you are developing it or you're deploying it. Tomorrow, let's say you're not in office, you're sick, or you're out, right? Or someone else want to pick up, it becomes very easy. They don't have to call you, they don't have to go through the documentation. It becomes a very repeatable template. So that's exactly the CloudFormation is used for. As you can see this example, there are many services out there, right? DynamoDB, S3, EBS, IAM. It becomes very difficult, as I said, like to wire. Whereas if I tell you I'll package everything and you just go and deploy this CloudFormation, provide the parameters and deploy, you will love it. I don't have to do anything. I know pretty well about my application. I can take care of that stuff. So there exactly, uh, CloudFormation helps you. In simple term, it allows you to create and model your infrastructure without having a problem of manual action. That's the best practice of CloudFormation, that you really don't have to worry about that. As well as, if we, I mean, I know security and all those things you guys are pretty new, but in industry, it is very important that you always work on a principle of least privilege access. That simply means don't give full access to anyone. Like, always start from very bare minimum, and then you slowly and steadily give them the required access. CloudFormation can also be think of helping to streamline those accesses, that you don't have to give the access to humans. You give the CloudFormation, and CloudFormation takes care. So that's about CloudFormation. Best example is Expedia. Expedia is like an online booking platform, and it's not just Expedia. I'll tell you honestly, every solution as of today which you pick up in the market, for sure they are backed up by DevOps stack. When I say DevOps stack is heavily relying on CloudFormation, the entire CI/CD, serverless, for sure. Those are the couple of things you will see. The entire, any application you pick up, you Google it on internet, you will see these are the common services you will see, whether it's machine learning, whether it's any data analytics, whether it's any application development. This CloudFormation CI/CD has become a very core construct of any architecture or any design which you do. And that's how we are learning this entire 3 sessions kind of a DevOps series, because that will help you to kickstart your journey in DevOps, which is like a core of any solution what you have. Now going to in detail and understanding, right? So far, more of theoretical what we have explored. If you really want to go understand how it works, what's the magic secret sauce? So there are 3 things. When you talk about CloudFormation, there are 3 concepts on a high level you need to understand, or I would say terminology you need to understand. One is the template, second is the CloudFormation, third is the stack. Okay. Template is like your script, like how you have your Python script, template becomes a JSON script. Okay. JSON or YAML script. That becomes your template. Second is the CloudFormation, where you upload your template from your local or from your S3 and the outcome with CloudFormation. So CloudFormation internally execute. First, it compiles your template, performs that your entire template syntax wise it is correct. Compile, that means compile the template and then execute the template. And the output of execution is the stack. Stack is nothing but like a package of the resources which you have declared in this template. So remember 3 things: template, CloudFormation, and stack. I'll take a pause here. Any questions so far?
No, sir.
Okay. Moving towards the next, right? First, all resources, what is CloudFormation? If you go again, right, after understanding that in a very much technical or detailed way, all resources required by a user and application can be deployed easily through template. The important thing of CloudFormation is also reusable. And the last is you can make reuse this template with things. If I talk about like how exactly CloudFormation can help you to reuse, right? We just understood like in first, like very high level, it can help you to reuse in terms of your parameters and all. But technically in ground reality, there are much more things required outside parameters. Like in the first slide, I made it very abstract because that was new. But if we now understand very core, there are many other things that are there. I mean, many syntax, many supportive functions, which CloudFormation provides to make it more dynamic across different environments, which you will learn in the demonstration. Now, how exactly what's the flow of CloudFormation work, right? So first, if we talk about the 3 concepts what we had, if I repeat that: template, CloudFormation, and stack. Same you will see here, right? First, as a developer, you design your infrastructure, whatever the infrastructure you need, maybe an S3 bucket, maybe EC2 instance, and IAM roles. You define in terms of YAML or JSON file. Then you upload this into S3. So there are 2 perspectives. Either you can do it from your local, either you can do it from S3. But by default, let's say if you do it from S3, well and good. If you do it from local also, behind the scene, AWS takes that template from your local machine, put it into a default S3 bucket. So whenever you start working on CloudFormation on AWS, CloudFormation itself creates a default S3 bucket to store its detail, right? Like the stack it wants to launch. So we'll see the demonstration also why I'm telling you that it takes it, right? But by default, even from local also, it puts into S3 bucket. It generates a link of S3 bucket, I mean the link of the template, and then it gives to CloudFormation service, which you can do it via console. I mean, again, the same philosophy what we have. There are 3 ways you can access any service: via AWS console, via AWS SDK, or via AWS CLI. Same in CloudFormation also, the rule apply the same. You can create or launch a CloudFormation. I mean, you can launch a template via AWS console, via AWS SDK, or via AWS CLI. Those still remains the same. And CloudFormation deploy the outcome, which is called as a stack. So this is how the entire flow works like. And again, there is more a level of automation that you can embed, right? Now someone can also say, sir, I don't even want to launch the CloudFormation every day. It should automatically come and it should automatically deploy, right? Those kinds of excellent or intelligent automation you can also do over and above, which we will learn in the 3rd session, like how we can even automate this process. And I don't want to do it. My job as a developer, I will just write the code, put it into my code repository like GitHub or anything. There should be a way which even takes care from GitHub to everything. I don't want to do that. Those kinds of advanced level automation we will see in the next session. Now quickly learn the different concepts of CloudFormation. So we understood, right? There are three concepts what we have explored: template, CloudFormation, and stack. So template, as I mentioned, this is a very important thing, and we heavily focus in this session on template, that what exactly the JSON YAML format is, how we can define parameter, how we can define resources, configuration action. Those are the parts we will learn in the template. CloudFormation, as I said, is an AWS service. It becomes very simple. Create the stack, delete the stack, update the stack. So it's more about managing your entire execution of the template. And stack. Stack is, as I mentioned, the packaged of all the resources, right? How we can, I mean, a simple example of stack can be like a zip file. How many different files you have, whatever kind of files you have, maybe TXT, JPEG, PDF, EXE, anything. It may be starting from one file to 10,000s of file. Zip file zips everything into one single package. That's exactly the best example of thinking of as a stack. Stack, what different kinds of resources you have, starting from one resource to thousands of resources, it will zip under one package. That one package is called as a stack. Now, let's, as I mentioned, we'll focus heavily on the template part, because that's a very core construct. And as a developer, you really have to understand, I mean, stack and CloudFormation are very important, but the core construct is template, because that's how you're going to work on the CloudFormation. So when it comes to template, right, the life cycle perspective of the template remains is there's an original stack, there is a change set, and then there's a CloudFormation. What this means is, right, ideally, whenever you're writing, let's say, any program, where you write a program in Python, you write a program in Java, even in your laboratory, you write hello world. Let's say if I talk about Java, you write public static void main starting from that, and you just see, okay, is my construct of my library, my class, and my public static void main function is correct. Then what you do is first you test that, which is a basic ground zero. Then you will add new function to accept an input from the user. Then you will do and one more function, which, let's say, do arithmetic operation, addition. Then you will add one more function, right? So if you see this trend, you don't write one entire program and then you compile. You will take slow, one step at a time. First one thing, test it. Second thing, test it. Third thing, test it. And at the last, that this step, you'll write something, test it, write something, test it. And this is how it works. Same is the concept. As I said, CloudFormation also, or template also, works in the same function. You have an original stack. The original stack can be as simple as one single resource without any best practices. Then you deploy that, test it. Is it works? If it works, then you will change set, right? Change set is like an iterative. You keep adding new features, new functionalities, new features, new functionalities, and you keep executing it. So this is more like a circle. Original stack, add change, view change, execute, CloudFormation. If that works, again, play around with it. Again, play around with it. Unless you get the final outcome, that's how it is, right? As I said, CloudFormation is very complex kind of application. It helps you to automate it. That complex application can be of 10 resources to 10,000 or 20,000 of entire configuration. You can't just keep bundling everything and at one go you test it. The output for sure is going to fail. So you have to take that small approach, break it down, test it, again come back, make the changes and test it. So those all life cycle CloudFormation supports, or templates precisely supports. Construct, I mean, any programming language do have couple of features, right? Like if we talk about Java, you have basic libraries to play around, to take input from keyboard. You can define your class, you can define your methods, you can read a file, right? So by default, Java provides the different libraries to you, or different inbuilt methods to do that. Similarly, template provides inbuilt resources or inbuilt kind of functions to do all those kinds of things which is required, right? Things like defining the resources, things like make the template reusable, things like take the parameter, print output. Those are the different kinds of 9 kinds of main high level objects or different functions CloudFormation provides, right from format, version, description, metadata, parameters, mapping, condition, terraform, a transform, resources, and output, right? Those are the 9 different objects are there. We will learn in upcoming slide what exactly each of this object is important, why this is important, and what it can help when it comes to the CloudFormation. But do remember, CloudFormation template supports both JSON and YAML. And when it comes to JSON perspective, JSON and it supports both JSON and YAML. And when it comes to the objects, it supports 9 different objects. Now, this exactly your entire template look like, right? When it comes to the template, this is how it looks like. It has your entire JSON site. I think you all guys are familiar. It like JSON series of object, right? In this entire thing, you have different objects. While template version, you have your description, metadata. Those are the different kinds of object you have on the left side. Whereas on the right side, it is same declare in a form of an YAML. Like how you can have the YAML perspective, the same has been declared in the YAML side of the stuff. So that's how on a high level your JSON and the YAML template look like. Right now, let's understand each and every object of the template. So do understand this is very important in the entire, I would say, today's session. This section is very important, the template structure, right? So this template structure is a sample one to launch an EC2 instance and deploy an Nginx. So first, starting around the different side of it. So template format. It's an optional thing, but it is a to AWS, right? So the template which you write behind the scene, as I said, CloudFormation is going to compile.
Hello, sir.
Hello.
Sir, your voice was not proper in between
Can you hear
when
me
you
now?
came to this slide.
Can you hear me now?
Yes, sir, we can hear you.
Okay, thank you. So yeah, in this entire session, cloud template structure, this particular slide is very important, right? So this entire example on the left side is deploying an EC2 instance. This EC2 instance will include everything. Like in simple, this EC2 instance is going to launch an Nginx server in it and open a port 80. But as you can see, this entire thing, we will dissect it and we'll understand what are those 9 objects and why that has been important and which is the mandatory thing required. Starting from the top, which is around the AWS template format version. So if you remember in the beginning slide, I mentioned that you write a template and then you compile, and CloudFormation compiles the template, executes it before telling you that, okay, before launching the stack. So this template version is very important to tell CloudFormation which version of template you're using. By default, this is the version, okay? And again, this key is not mandatory, it's an optional, but it's always good to add, like how you add comments in your Java and Python code. Similarly, it is very good to add that. Description, it's very important to talk about what this CloudFormation is going to do. Let's say, as it is very clearly mentioned, launch an EC2 instance running Apache and expose default page to the internet, hard code to work only with US East. Very clearly defining what exactly this tag is going to do. This becomes very helpful when you have multiple different stacks and you don't want to go each and every stack, understand, spend your time and other thing, right? From one layer, at least you should able to connect or high levelly understand what this tag is going to do. The description is helpful there. Then you have parameters. Parameters is very helpful to take the input. Now it might be possible that let's say you're defining this template for your own team. Tomorrow there is some new team that comes up. They say, okay, hey, you have write a template. Now, can you give me the template? I also want to work on Nginx. Which you will give it. Okay, yeah, it is. Now he wants to launch, let's say, EC2 instance T2 large. You have developed a template which is based on EC2 instance T2 micro, and that person wants to launch T2 large. Now, there are two options. Either you can take the input at runtime from him and make his experience much more easy, or you hard code it and he has to go around, make some changes, play around. It might even break. It may be very difficult for him, right? We'll always try to make simple things, like how even in Java and other programming, you always try to either read a file and take the input or take it from keyboard when you're executing it. Similarly, parameter also will do the same thing. When you're executing the template, it will ask the user, can you give me the property value for this particular parameter so I can dynamically substitute it wherever the parameter is required. As simple example in this particular, in reference to this template, is EC2 type. Like EC2 type can be T2 nano, can be T2 micro. First of all, there are multiples of EC2 type. I think you guys know about it. You can also restrict what kind of values are allowed, right? Like starting from T2 large, T2X large, other stuff. You can also have the small one, like T2 nano or micro. You know that your application won't need larger, so you can have the limited to this one. And then you, in the resource section, again, this parameter section is also not mandatory, but again, it is very important, as we understood, to make your template reusable. Resources is the only section in the entire CloudFormation template important and mandatory. It's very simple to even understand. If you don't, I mean, CloudFormation is there to automate the resource, and even if you don't define the resource itself, then it makes no sense. What are you launching CloudFormation? So from that logic perspective also, resources is the very mandatory section. And in resources, as you can see, you're defining the different types, right? In this template, they have defined AWS EC2 as an instance. Then you define the different properties like tagging of it, the instance type, what kind of image you need, security group, and other stuff. You can also do something called as bootstrapping. The bootstrapping is very important. So if you remember the example which I gave you, that okay, you need to launch EC2 instance, install Python, CLI Nginx in it. Now you can, as a name suggests, infrastructure as a code. So now you can launch EC2 instance, but still, if you want to go ahead, install that out manually, you will hate, like, okay, why? I mean, can you get me something which can even automate that part? So bootstrapping or user data is that exact functionality which can also help you to automate. So whenever the CloudFormation will say I am complete, that simply doesn't mean that it has only launched the EC2 instance. That also means that it has launched the EC2 instance, as well as whatever the commands you have given, the scripts which you have given in user data section is also completed. There are other complex ways are also there in order to ensure whether it is successfully executed the user data or not, which are like outside this session, I would say, on an advanced concept. But there are other more intelligent way also to validate the output too. But for now, for this session, those kinds of functionality also CloudFormation provides outside provisioning the resources. And similarly, you can see one more resource, which is security group, and then you can refer it. One important thing is, can someone tell me when this CloudFormation is going to execute, which is the first resource the CloudFormation is going to launch? I mean, first resource it will provision. Is it security group or is it EC2 instance? And why so?
Security group.
Why so? Why it will launch security group? I mean, technically, I've defined second the template as security group. Why security group will be launched first?
Sir, first, while we are providing EC2 instance, we have to configure the security group. So by that only we can think that security group will be assigned first, and then EC2 will be done.
Okay, okay. I would say the answer is not exactly what I was looking out, but as you correctly mentioned, right, that security group is required. Let's say for an example, you have an S3 bucket. You all know S3 bucket, right? And you have a Lambda. Now, if I want the S3 bucket, which we learned in the last slide, that I want to define an event, I want to map an event with S3 bucket to Lambda. In that case, there is no, I mean, I would say no dependency, right? So how exactly S3 bucket should launch first? Like, why exactly the S3 bucket will be launched first and then it will be wait? Is it just that EC2 instance need CloudFormation? I mean, sorry, EC2 instance needs security group. That's why it is launching, or you have really defined something in your CloudFormation which makes it to do in that way? Because we know, as we are working on EC2 instance, so we know that EC2 needs security group. But CloudFormation doesn't have that knowledge. It's not that intelligent that it knows that, okay, EC2 needs security group. Can someone help me with that answer?
So for inbound traffic, or so we have to specify it. So it will first go for security group then.
Sir,
Hmm.
Sir, I guess if we don't specify the security group, it will take the default, assign default security group.
No, so you guys are not getting my question. So my question is not in terms of the security group. Okay. Not that why you need security group or why, I mean, if you don't give security group, right? You guys exactly mentioned all the right answers. Security groups help you from inbound, outbound, and all other stuff. My only question is how my cloud formation template, when I deploy this cloud formation template, right? How my cloud formation knows that it first needs to deploy security group and then only it needs to launch EC2 instance. Cloud formation doesn't have that intelligent like us. That EC2 will need security group, so I will need security group first. Then how cloud formation knows about it? Clearly observe the code snippet, you will understand it. Any answers? Okay, let me not take much time. So I'll tell you. Very simple. If you see line number 26, what are you defining here? You're calling another resources, correct? So that means here, I mean, in simple, in programming language, what you can call one particular module from another module, correct? In cloud formation also you're doing the same thing here, but the difference in cloud formation that comes is cloud formation is not mapping the dependency at the runtime. Like when it is already in execution, half the way it will understand. Before even it start executing it, it creates a dependency graph. So cloud formation really knows what is my dependency graph is. And in that dependency graph, it sees that, okay, it's like a stag. It sees that, okay, before I launch an EC2 instance, the designer has asked me, or there is a requirement of security group. So I have to first launch security group, get the ID of security, and then I have to deploy EC2 instance. Is the point clear?
Yes, sir.
It can be reverse also, right? It can be very simple as, now why always it will always go as a resources and will EC2 instance, EC2 web server dot public IP. So that's how always do remember. Cloud formation has its own internal dependency graph. Again, there is no much clarity what data structure it stores or how exactly it does. But there is a dependency graph which cloud formation creates internally. You can think of like very simple, if I can put like a map that, okay, what are the different resources I have, with different resources are required. The common time, I mean, most of the people also make some mistake is circular dependency, right? Deadlock kind of thing. Like for example, security group required by EC2 instance, maybe security group needs some other resources that some other resources need EC2. Like you would have learned in your operating system, the deadlock scenario, right? Most of the time, people also, when they're designing the larger workload, they face this common issue of deadlock, like the circular dependency. One is dependent on other is dependent on the third one, and third one is dependent on the first one, like a chain. Then you cannot break that chain. That's a common mistake, but for now, just do remember that this how you can introduce the dependencies very implicitly without calling it out that this is a dependency. And this can be anything, not just security group. This can be even IAM role. This can be any other thing like an S3 bucket. So those kinds of thing you can call dependency. So we will quickly recap around metadata as we understood, right? So metadata is the additional information about the template. Like similarly, it works with description. It provides more about the template perspective. Description we understood around it. Parameters we understood that any values we need to pass at runtime is called as parameters. Mapping is very important, a kind of a lookup table, right? We'll see in upcoming slide. Mapping is very important. Like for an example, if I tell you that, okay, if you're launching this cloud formation in a development environment, you should use only T2 micro, but when you launch the same thing in production, you should use T2 large. That kind of mapping also you can do, as well as I am pretty sure you guys would have seen this, or if not, then what happens is this AMI, right? You all know machine EC2 needs an AMI. AMI is like an image of any operating system. That AMI ID, there's a unique identifier for each AMI. That unique identifier always differ from region to region. So the AMI ID for, let's say, Amazon Linux 2 for Mumbai region will be different versus the AMI ID for Amazon Linux 2, which is in North Virginia, US, or it may be even, let's say, London. So all those AMI ID changes. Now, if you want something that your CloudFormation is very reusable and dynamic, one person may be, let's say, launching in Mumbai, the second person may be launching in US, third person may be launching in, let's say, UK. How you can have this dynamic thing? So that also can help via mapping and condition. As I said, that if, let's say, you want that kind of thing, that in development environment a person should only launch T2 micro and in production T2 large. So that kind of mapping and a combination of condition you apply, which help you to do that. We'll see in upcoming slide and as well an example around it. Transform is another way of reusing, right? How you do an import java.lang in any Java programming language. Similarly, transform in that way, that anything which is already defined, you import that. Resources, as I said, the only mandatory section which help you to define resources. The resources can be anything, right from security group to EC2 instance to S3 bucket. Output is the output of the resources which you deploy, right? Which can be anything. Even this, like as we see here in this example, the web server public IP address. So that's about the template and the structure of it. I'll take a pause for a minute. Any questions here?
No, sir.
Hello,
Okay.
sir.
Yeah.
So if we are assigning Lambda, so we have to configure IAM role, right? So
Correct.
it will be mentioned in Lambda resources only, or we have to separately mention it out?
According to you, what is IAM? Is it a separate resource or is it a Lambda resource?
Separate resources.
Exactly. The answer is separate resource.
Okay.
Even, I mean, the best example, right? Here you can see security group. Security group is the same example what you said, right? I need IAM resource for Lambda. Similarly, for EC2 instance, you need security group, right?
Yes, sir.
So security group we define as a different resource. Even I'll tell you, everything is a resource, and then you have to plug. You guys know Elastic IP, correct?
Yes, sir.
Elastic IP also, if let's say for an EC2 instance, if you want to attach Elastic IP, that will also be a different resource, and that resource, then you first launch that resource and then you tag that or provide that resource to EC2. So in your example also, right, in your question, first you will launch IAM role and then you will add that IAM role to Lambda. So when you're deploying the Lambda, then you will provide that refer to this particular ARN of the IAM role which I deployed in this CloudFormation. Clear?
Yes, sir.
Any other questions? I'll tell you, this is very important. So please, again, if you have any other questions, do ask me, because after this, all the advanced concept, the demo, and all those things will start, which will go very fast paced, fast mode. So please let me know if you have any other questions.
Sir.
Yeah.
Sir, if I am deploying an EC2 instance through for CloudFormation, then is CloudFormation a regional service? Like where will my EC2 will be launched?
That's a very, very, very good question. CloudFormation, yes, is a regional service. So I will say there are multiple other functionalities are also provided outside to that. But for now, CloudFormation is a regional service, and the region where you are deploying the CloudFormation, the resources will also get deployed within that region. Does that answer your question?
Yes.
So for example, here I'm launching an EC2 instance, right? So by default, this will launch in EC in North Virginia only. Now, again, there are some other ways also you can do. I mean, for a very complex enterprise setup, a CloudFormation do also provide something like StackSat and those kinds of other features, which can help you to launch the resources in cross region, like another region and other stuff. We'll keep out of it. But by default, if you don't provide any explicit way, by default, it will always deploy the resources and within that region itself. Moving towards the next, the metadata. I think we didn't saw an example of metadata, right? So as I said, metadata is very important when it comes to providing the CloudFormation, right? So here you can see the metadata. Now, parameter group, default EC2 instance, configuration and all, right? So if you from this particular stuff, it becomes very important to understand that if you have any sorts of label, first it provides a label. If you have any sorts of, let's say, parameters and all, it help you to describe more about the parameters of your this thing. Okay. Mapping, as I said, the best example I gave you, right? Okay, region wise, if you have US East one, you have US West one, EU West one, and if you want to have an AMI at the runtime, this is how you can do. You can define a mapping, and at the runtime, based on the region, right? Based on the region where you're deploying it, it will automatically pick up from this map. And this are the core thing, right? Things like condition, mapping, parameters. These three things are very core construct when it comes to make your template reusable. Any enterprise or template which you pick up, any cloud formation, you will always see these three things as a part of it, because that template is not just meant for one account, not for one region, or not for one environment. It has always been designed in such a way that you pick up and run that template in any account, any region, that should work. That's the true reusability of any CloudFormation template. Next, condition. So as I said, right, by default, any programming language, you have something called as branching. Any condition, you have if else, you have for loop, you have while loop, do while, any sorts of like ternary operators. Similarly, in CloudFormation also, there are different functionalities are given, which is also called as intrinsic function. Like in simple, you can refer as an internal function. Like when you're thinking about it, you can think of like an internal function provided by CloudFormation to do more intelligent way. So as we understand, as I mentioned right in the beginning, that okay, let's say if you're launching a kind of a CloudFormation across two environments, development and production, and based on the environment you want to define the EC2, then you can use things like fn if the environment is dev, then the EC2 type is X. If the environment is prod, EC2 type is Y, right? Or if the environment is dev or the environment is prod, you use EC2 as, let's say, XYZ. Those kinds of different things you can do to help you make your cloud formation much more intelligent, right? You can also do so. There are, I mean, if you really start practicing the cloud formation, you will understand many a times many resources needs either IAM role name or the ARN. Now the problem there comes up is, if you, I mean, by default, to make it process simple, people always take ARN or role name as input, only one thing, but they need, I mean, based on the resources, they might have to provide both the option. So then at the runtime itself, with help of things like fn sub, fn equal, they try to form that pattern of ARN with help of the role name. So those are the different way also you can also process the parameters given by the user at the runtime. Let's say very simple example, bucket name. Now it is very easy to provide bucket name, Sanchit-Jain, rather than AWS S3 colon that entire ARN of the bucket, right? No one is going to remember the bucket entire ARN, but your resource needs an ARN. For some policy purpose, you need to provide the entire ARN. Then how are you going to do it? There exactly, you can ask the user at the runtime, give me just the bucket name. But when you're running that cloud formation, you write the code in such a way with help of intrinsic function that you process it and define in that pattern. You substitute in simple. You substitute the value of bucket name in that defined pattern, and at the runtime, you create or generate the ARN. Right? So this is an example, as I said, of conditions. The same example, like if you have environment type, and if you want to compare around the condition and give that perspective. So this is how the code snippet looks like. And again, all, I mean, the AWS documentation, I'll give the, I think I've given the GitHub repository to your faculties, and in that README file, there is a documentation is also there of all the cloud formation, how you can play around with the syntax. The more important thing is you don't have to mug up the syntax. You always have to focus on a core construct, the best practices, how you have to write it, and thoroughly follow the documentation given by AWS of those syntax. If you do that, you can easily design and develop any cloud formations. You don't have to remember, like someone might say, it's very complicated. I can't remember like all the properties of EC2 instance, which tomorrow it might be 10 other things that AWS launch. So how can you help me out? How do I get the latest thing out of it? So always documentation of CloudFormation is the latest. Follow that, and you should be knowing what are the best practices of writing your CloudFormation template, irrespective what different sources you want to launch. If you know that, you can easily write a good CloudFormation template. Now transform, as I said, right, if you have already an S3 bucket and you want to take around it, you can easily take that and make a reusable template. Stack, I think I've given a very best example. If you think of like a zip file, then that zip file is in CloudFormation is nothing but a stack. And now we'll go with a demo. Give me 1 second. Let me get the demo lab set up. Just give me 1 second. I'll stop sharing my screen. In meantime, if you have any other questions, please feel free to post your questions.
Hello, sir.
Hello.
Sir, how we can share the template of this across the regions?
Sorry, you're saying how to share the template across the region. Okay.
Yes, sir.
Let me ask you, why at the first place you need to share the template across the region? Like, what's a use case? Why do you think so you'll ever come up to share the template across the region?
Sir,
Sorry?
sir, suppose we have a template of our own and we want to share it to one of the AWS structure of our company, which is situated in another region. So
Exactly. Now, okay. Let me ask you one question, one more, okay? And again, I'm not punishing you or something for asking the right question, but I just want to understand, right? I want to explain you that how exactly is sometimes the best way to adopt simple things. If the same would be with your Java code, how would you have done that Java code? If let's say Java, Python, or .NET, right? Any programming code. And if the same you want
sir,
to share it, how would you have done that?
simply by mailing that thing.
Mailing that thing. Okay, that's one way. Have you heard something called as GitLab, GitHub, code commit?
Yes, sir. Yes, sir.
Would you feel email would be better or code commit or GitLab would be better?
Code commit or GitLab.
Right? Same is the answer.
Okay, sir.
Same is the answer that you can use any code repository. The code repository can vary from GitLab, GitHub, or code commit.
Okay, sir.
Right? Because I'll tell you the problem. See, I know you guys have done the cloud practitioner, but one thing always do remember, always try to adopt the most simplest route. The more simplest route is anything. I mean, this all thing when it comes to cross ratios, cross region sharing, cross account sharing, becomes more complicated for any live resources. What I mean is live resources. It means is the resources is already live, up and running on AWS, and you want to share that in another account. But things like code, right? Any application, any infrastructure, any CI/CD pipeline, any of your application is not very live. They are more in the stateless of a nature. They're the best way of making them cross-region available or prepare yourself from disaster point is make more replica across different source, and again make it more versionable replica so you can even look backward as well as you can repeat in case of that. So things like even your code, Java code is there or any Python code, always try to use your code repository. That's the best practices. Neither, I mean, nor it will only help you to understand how exactly the code has been written and who are the people who have deploy that in the, I mean, deliver the changes in the code commit in the past, what are the new changes, as well as it will give you a backup copy. Okay. Clear?
Yes, sir.
So this is the code GitHub repository. Like as I said, I always by default refer to use GitHub not only to share but also to do it, because the best part is I can track the version, right? I can not only check like who are the people are looking forward or making the changes, but also it becomes very easy if I want to keep updating my repository. It becomes very easy that I keep uploading my new information here, and even for you guys it becomes very easy, right? So it's not about just this session. If tomorrow you want to see that, okay, there is something else what this guy has done, it can help me. You can look into this repository or GitHub, not just mine, any developer that can help you to understand, right? Now with that, let me quickly go ahead and bring up the demo. So that in the demo, right, what we are going to do is we are going to do very simple thing, almost the same thing what we have understood in the template structure. We will first deploy an EC2 instance. We will run an EC2 instance, like we'll launch an EC2 instance. Sorry. We'll launch an EC2 instance, set up a web server, a LAMP stack, have an PHP application via user data, expose on 80 to 80, and finally we'll just take the IP address, put it into my browser, and we will run that. Like something like this can be a very simple architecture. Okay. Now, first what I'll do is I'll start at least have the CloudFormation ready. So I'm deploying, there was one question that CloudFormation is a regional service and all. So I'm in Mumbai region and I'll use the CloudFormation. So EC2 will also get deployed within this region. Now I have two options. Either I can upload it or I can provide S3. So I'll do an upload. As I said, right, when I was explaining to you the flow, how CloudFormation works, one thing I mentioned, even though when I upload my template locally, by default, the CloudFormation first uploads the template to S3. Why I was telling you that? Because of this. See, I've select upload a template file. I've choose the template file from here. Still, you can see the S3 URL is this. Okay. And also from a designer perspective, also you can look into it. Many times you need to give the architecture, right? 1 second. So you need to give the architecture of this thing. So this is how exactly the architecture can look like. So if you understand, very simple. I had a template and I want to just understand or visualize the template, that also you can do. So this is that UI I was talking about, which is the drag and drop. So you can see all the resource type on the left side are provided, right? And even if you expand one of them, you can easily understand what are the different properties or different stuff that particular resources support. So even if you're not coming from a very programming or a very technology background and want to still do it, but know how to play around, you can easily take care of this stuff. Clear? And again, the JSON can be both. The template can be in both the JSON or the YAML. By default, it can easily convert that out. Make sense? So what I'll do is, we'll again go CloudFormation. It will see the by default it is uploaded. I'll click on next. Here, I'll give a name. Giving an environment, again, dev, test, prod, you will see, I'll explain you the template, what I've designed. The AMI ID, the way I'm dynamically taking the AMI ID without hard coding it. Next, you can provide the tags. You can provide any IAM permission that's required and other properties, which we'll keep as is for this demo perspective. But you can do more good stuff. Like let's say if your CloudFormation fails, you want to get any notification on Slack or any SNS notification, those kinds of all kind of stuff you can do, right? With notification, you can do it. You can have a timeout also that, okay, my CloudFormation should be launched, let's say in 5 minutes. If it is not, then fail it. The rollback configuration also. So rollback, I missed out, but rollback is very important thing. Okay. One of the important thing of CloudFormation is it's a very simple service, right? So if it fails, it will destroy or delete every resources which got successfully done. And if it is successfully deploy, then it will deploy all the services. So what I mean by that is, let's say for an example, you're launching an EC2 instance. And in that EC2 instance, you're given a subnet ID, or let's say you're giving a security group. Now, if that security group doesn't exist, for sure your EC2 will fail, right? Because its security group does not exist. And in that template itself, you're also launching different other resources like S3 bucket, let's say Lambda, IAM role. So what do you think? What would be when let's say EC2 failed in case of security group not exist? What will be the state of other resources like S3, IAM role, and Lambda? Can someone help me? What exactly will that be still up and running, or will that get deleted by CloudFormation? Can someone help me with that?
Will get deleted.
Why?
Sir, because of this rollback.
Hello, sir.
Hello.
Hello.
Yeah. Please go ahead.
So it will be not deleted for some duration. It will just roll back it. And if you want to get it, we want to get the data, successful data in another storage, we can do it at that period of time. And after that period, it will get deleted. So for a particular time, it will be staying, it will be on the stop mode.
Okay. The answer is it will get deleted. It won't be in a stop mode. It will get deleted. Rollback means the same thing. So rollback, simple. I mean, if we talk about rollback, word means going back to the previous stage, correct? That means when you see any cloud formation that says rollback in progress, that behind the scene, it is deleting all the resources which got successfully deployed. Now, I think your answer was also partially correct. There are configuration in rollback. So you can also say, I think the stock property, yeah, in the stock property itself, yeah, roll back all the stack resources or preserve successfully provisioned resources. So you can, here in the failure option, you can also configure. By default, CloudFormation will roll back everything, but you can select and you can ensure that it doesn't delete all the resource, it just stay. This functionality is very helpful when you're troubleshooting it, because by default, if CloudFormation deletes everything, then how are you going to troubleshoot it, right? Let's say if something goes wrong in EC2 instance in the user data section and you want to troubleshoot. So if the CloudFormation stay, halt, then only you can do it. So this, from troubleshooting perspective, this feature will help, but default nature, it will roll back everything. And then you just delete the CloudFormation stack, but the resources behind the scene are already deleted. Clear? Any other questions on that? Okay, next, I'll click on next. So this is how the template is, right? This is a review page where you can see all the details, like the template, the parameters, whatever you have provided, this will come as a review. And this becomes the capability. Capability is like kind of the permission you're allowing CloudFormation, that CloudFormation is going to launch whenever the CloudFormation works with any of the IAM related services, CloudFormation needs an additional approval from you, or a kind of an approval that, okay, hey, you are giving me the permission to launch any IAM resources. So whenever you're working, or whenever your template would have anything with respect to IAM role, IAM policies, you will see this particular pop-up that comes up. And then you click on create stack. And this how the stack will look like. We will come back to this stack. I mean, it'll take like roughly around a minute or two to get that done. We'll come back to it. In meantime, I'll take you towards the code snippet. So this is the CloudFormation stack, what we have launched, right? As you can see, very important, I've added a metadata, which talks about like, okay, AWS configuration, you're giving an AMI ID to it, right? And again, as I said, this is more about describing more in at what exact the parameter, or what about the parameter is. more from a readability perspective. How you add more comments to your code. This is the same concept. In parameters, you can see that what I've given is the environment type and I've given the AMID. Again, this is the way, the best way here is, this is the way you can dynamically refer the AMID. So you can do things like mapping, you can do things like SSM parameter where you can do it. Let's say someone can also come up and ask me, right? Okay, we have very password. How I can store, how I can provide the password to my CloudFormation. Let's say you're launching any database. Or sure you need to have the password, username and password. How I can do that? This is the way at runtime you can tell CloudFormation, please pick up the password from system parameter store where the password is stored. The system parameter store is like a parameter store which can store secrets or the parameter as a plain text or encrypted format. And at the runtime, CloudFormation can pick up the value from parameter store or from secret manager, and you don't have to pass or get, because whatever the parameter you will give, it get printed on AWS console. But if you do it with help of secret manager in this dynamic reference way, it won't get printed anywhere. So those are the small tips or tricks I would say when you are working around with the CloudFormation security perspective. Then this comes the mapping where you're saying that, okay, based on the given parameter, which we have selected test in our case, what kind of EC2 instance the person can launch here? Is it T2 nano, T2 micro, T2 small? And the important thing will come is when you're actually instance type. So this is the map. In the map, you're providing instance type, instance environment type, and instance. So you're giving a kind of a map here, and you're telling that, okay, if the environment to instance type, which is this particular map, if what is the variable, and according you're passing to this map one important thing, which is the environment type, and based on that environment type, you're getting the EC2 instance type. So this is the map, and then finally you're doing a simple thing, which is you're doing in user data. Now we saw in the template section, the user data section was very simple. Here you can, I'm writing the entire PHP code itself here at the runtime. And this PHP code, I mean, just, I'm not sure whether most of the people know PHP or not, but very simple. What it's going to do, this is my URL 169.254, 169.254, which will help me to get the user data section of the same EC2 instance where the script is running, get the detail, and from that detail, I mean, instance ID, and then get the availability zone of it. And that what I'm going to print on my console. So console, when I say once the entire CloudFormation is done, the public IP which I'm going to get, the public IP and the DNS, I can take that and put into my browser. You will see this form of an output. And the same, the security group. Again, I would repeat, this is not at all a best practice to open the port to all. I mean, from demonstration perspective, for a demo thing, I've given port 80, but it is not at all recommended. Even if you're doing a POC in your own lab, please map to your own IP address. Don't use to all. And this is how the entire CloudFormation works. Any doubt on this CloudFormation template? Any questions?
No, sir.
Okay, cool. So now we'll go here. As you can see, the CloudFormation template is done. Okay, so here you can see the different logs and different events. Starting from timestamp, logical ID, create, and other stuff, right? You have the different timestamp, logical ID, status, and status region. That's what I think this all shows about what each and every step done. This is an event. Stack info is the same kind of like a review page, what we have seen. This is an event. This is the resources. Resources is like whatever resource in the resource section, whatever things CloudFormation is launched, the same thing will get printed here. Whether it's an SSM IAM role, web service IP address, instance ID, profile, or security group. The output section is where you can get the output section. So let's say if I hit this particular stuff from a demo, as I said, right, this might be my instance ID and this will be my availability zone, which how you can validate it. You can come up and say that, okay, hey, 1 second. How are you pretty sure that this is your instance ID? So what we can do is we can copy paste this instance ID. We'll go to the resources and you can see web server, which is launch. Instance ID is this. And again, you can even go to the AWS console. Like if you go to the AWS console, you will see that you can also verify this the same. So this is my instance ID. This is my instance ID and this is my availability zone, which is AP South 1B. Okay, so that was a quick demo about how to deploy a CloudFormation and how exactly you can work. Any questions before we move ahead with the advanced concept?
No, sir.
Okay, I'll delete this tag for a reason because I have used the security group open to 00. So this is how what you have to do, select and you have to delete. By default, you will see when you say delete, it will again do the everything. But one thing should always notice, when it is deleting it, it will delete in a reverse order. So nowhere in the documentation it is mentioned, but if you see when it started launching, it start launch from IAM role, security group and other stuff. And at the last, before the complete, it launch web server elastic IP. But when it is deleting it, it is launching in this. So this is something called as stag, last in, first out, right? The stag data structure. So you will see the behavior of CloudFormation is the same, that the way the resources get launched, it is a reverse when it comes to delete. The thing which get launched at the last will get deleted first. So if you refresh it, this is how the same stack order, right? First it deletes the elastic IP, that delete instance, and at the very last it will delete the IAM role. So do remember the small things, it will really help you. So this was a demo which we saw. Moving towards advanced concept, custom resource. Custom resource is more important. Many a times, let's say for example, you want to do couple of things, right? Things like, let's say you want to get a particular credentials or particular configuration from a different, let's say, region, or let's say from on-prem or from database, right? Now, CloudFormation is more, as I mentioned, is a declarative. You cannot use any functions and all the stuff, right? So custom resource is a way or a method via which you can execute a Lambda at the runtime. So when you're launching the CloudFormation, right, at that CloudFormation, when it is running, right, when it is executing, you can launch, I mean, you not only can deploy the Lambda, but you can execute a Lambda in form of a custom resource, which can perform the action. And once it is successful, it will help you with the help of a pre-signed URL, which tells CloudFormation that, okay, whatever the task you have given me. So this is a request. So let's go from this, right? So this is how you define it. We will see an example, but this is how you define it, right? You define type as custom.test. Then you have the ARN of the Lambda and the input. You tell the CloudFormation, and the CloudFormation, when it comes to this particular resource of custom, it will invoke the custom resource with this particular JSON input, right? You have stack ID, request ID, and other details. This goes to Lambda. Lambda, the code is already there in Lambda. Lambda takes this as an input, and then it performs all the actions required. The action can be anything. The action can be reading a value from database. The action can be, let's say, getting the credentials or secret from something, or it can be anything. And then once it is successful or fail, with help of pre-signed URL, it tells CloudFormation, here is the output. The output can be anything. The output can be a failed, the output can be succeed. And based on the output, CloudFormation can decide whether it want to continue the deployment or it want to fail. That's how the custom resources works. Any question in the custom resources? Should I assume this is clear? Hello, can you guys hear me?
Yes, sir.
So can you just repeat it once again in the quick way? So
Okay. So what exactly is the custom resource? Let's say if you want to get something from maybe some other region, maybe let's say some other account, or maybe let's say from on-prem, right? On-premise. Now, CloudFormation, as we learned in the previous slide, I mean, at the beginning, CloudFormation is more as a declarative for infrastructure, right? It does not have any like very intelligent way of it can go get something from somewhere and can do it, right? Okay, for sure, it can get to secret manager and parameter. But let's say if that information is not even in secret manager and parameter, it stores some other way only in some other part, let's say not even within your account, some other account, then how you can do that, right? You still need it with the help of CloudFormation. So there you can use something called as custom resource. Custom resource is that you code whatever you need, right? You write in Python or Java within a Lambda, and you within that Lambda, you execute what you need to do. It can be anything. It can be, let's say, getting a credential from a database, for an example, or getting a file from some other external URL or anything. You execute that, get that input, and based on that input, the CloudFormation, and based on that input, the Lambda can give the output to CloudFormation, and CloudFormation can decide whether it want to continue the execution or it want to fail there and roll back everything, right? So that's how custom resource works. And as we saw in this snippet, right? This is how you define your custom resource in the template. When the CloudFormation understand that there is something called as custom resource, it will invoke. I mean, generally CloudFormation is meant with an intent to provision a resource, right? But if you want to invoke a resource, invoke is at the runtime, right? Like you want to execute that particular resource, CloudFormation will generate this particular input JSON, which will be given to Lambda. Lambda will, based on the given input, Lambda will perform the required stuff which is there, and then Lambda will give the output. Now, output, it succeed, it failed. Based on that output, it will CloudFormation will get to know that what is the outcome it got from Lambda with help of pre-signed, self-signed or pre-signed URL, right? And then CloudFormation, based on the output from Lambda, will decide that if the Lambda succeed or failed, what the CloudFormation has to do next. Clear?
yes, sir.
Any questions here? Okay. Next is a nested stack. So far we understood about a template, right? Template can be one simple template, but as I said, right, when you're really working in any production or enterprise application, you cannot have like one template which has 10,000 lines of code. Like similarly, any programming language, what you do is you modularize, you create different methods, different file, different class, different interface, right? You modularize that particular code to break it down from multiple reasons. If something gets failed, it fails within that stuff. If you want to make a change, it becomes very easy. Troubleshooting makes easy. Similarly, in CloudFormation also, you can do the same thing with help of nested stack. In case of nested stack, right, one simple thing I can do, I can just plug everything in one go. The VPC, IAM, EC2, just make the entire menu out of it, right? Or other way I can do is I can make it more granular. I can have a different for VPC, different for IAM, different for EC2, and then have a one controller, the parent, where I plug everything. Similarly, the same is the concept you have in your Java. You have the main method, right, where you define the public static, and then you have all different classes where you have different methods. Same is the nested stack. One is the controller where you have the root, which is the first template you deploy, and in that template you define the rest of the templates, location, and the parameters that's required. And as and when the root templates get executed, it will invoke the other child templates with the input that's required. And this way you can break down the entire complex application or the complex CloudFormation stack into multiple smaller templates. Any question on this? We'll look into both this concept into demo, but any questions here?
No, sir.
Okay, now we'll move with the demo. So here, what I'll do is we'll quickly go ahead and we'll demonstrate this particular stuff of custom as well as this. So I'll move towards my AWS console. So this template would have by default been deleted now. First, what I'll do is before launching the CloudFormation, I'll go to the S3 bucket. Okay, so in S3 bucket, you'll see there are two buckets I have. CFT demo source bucket, CFT demo destination bucket. Now we can see the demo destination bucket is very empty. There is nothing. And source bucket do hold something called as code and CloudFormation. What I will do as a part of the CloudFormation, when I'm launching the CloudFormation, I will ask CloudFormation to execute a custom resource, and this code and CloudFormation template, move it to another bucket, the destination bucket. Okay, so that's what we'll exercise. We'll do very simple, and that is a very simple thing. The whole idea is I'll walk you through how exactly you have to define custom resource. When it comes to exact custom resources on you, which we have learned in the last session, how we can define the Lambda. It's all about that. The process is going to be the exact same, nothing new. You upload the template, you go next, you provide here you have to provide the bucket name. In our case, first we'll provide the bucket name. Let's take the bucket name from the URL. Okay, then you have to provide the file name, which is the object name here, and the prefix is code. So in that code is also right. Now we have to give the destination. Okay, so we have given the parameters. This template will even work in your case. I don't have to give it, right? That's what the dynamic thing is. Everything I'm giving as a parameter. I'm not hard coding anything. So next, the option remains the same. I'll click on next, and you will see the review page. Again, since I'm launching any IAM related stuff, I'll do acknowledge it and create stack. So in meantime, this tag get launched. Let's quickly get back to our text. Parameter description, parameters, condition, right? Condition as I'm giving around destination bucket or use default bucket. Now this exactly is I'm creating an S3 bucket or not. So condition is very important, right? Let's say if you already have a resource or you want to newly create a resource, that also you can do with condition. So here you can see, right? Here I'm ensuring if I'm not providing a bucket at runtime, it will by default take this and it will create a destination bucket. So here you can see if I'm not providing a bucket, it will create automatically bucket. So that makes CloudFormation template more intelligent and more useful. Okay, since we have already provided, we're going to skip. Here is the IAM role which I'm providing for the stuff which is required. This is the custom resource. As you can see, I'm defining the custom resource here. This is a syntax. In custom resource, I'm saying CloudFormation custom resource. First, what you need to resource, which Lambda you need to resource, right? So I'm giving the Lambda name, which is this particular Lambda. So whenever the custom resource CloudFormation comes into this, it needs to invoke the Lambda name as copy objects Lambda function. Region I've given already, which is the by default where the CloudFormation is running. The bucket name and the source bucket, the parameters I've given, the prefix and the object I've given. Okay, so this becomes my input. So do remember, the important thing you have to pass here is service token. Service token means which Lambda function you need to provide the ARN of the Lambda function, which you want CloudFormation to invoke in a form of a custom resource. So that is done, and then this becomes a simple Lambda function what we have. You define, and this is my exact Lambda code in Python, which I'm copying. This how you define the custom resource. There are additional modules are there which you need to ensure, right? So if I talk about CFN response, right? So you will see everywhere I'm giving a CFN response, even for succeed, even for failed, succeed, right? The important thing is with help of CFN response, CloudFormation get to know whether the Lambda is executed, and if it is executed, what is the response? Is it failed? Is it pass? If you don't send a CFN response, CloudFormation will not even know what is the state of Lambda, and it will assume I have to wait because my Lambda or my custom resource is not completed successfully. So many a time people you will see on Stack Overflow or any other website, people will always talk about, I have a custom resource in my CloudFormation and a CloudFormation is waiting from 1 hour, 2 hours, it's not doing anything. Because the biggest problem is you have failed or you have not defined CFN response, or you're not, in case of failure response also, you're not defining the CFN response. That's why the CloudFormation is waiting for the response and it will by default time out after 90 minutes and then you have to go and delete it. So do remember this. This is a very common problem people generally face when they start working on CloudFormation. Otherwise, the entire syntax of the things remains exact the same. And the output, you see the description. Okay. Now we'll refresh. As you can see, the CloudFormation complete. As I said, CloudFormation completes, that means it has successfully executed the custom resource. Okay. Now what I'll do, I'll go to the destination bucket and we will refresh it. By default, there was nothing in the bucket when I launched CloudFormation. It created a cold folder and it moved it just now from the timestamp. So that's about how exactly, and this is a very simple demo. As I said, this is a very simple demo of custom resource. You can make it more complex and you can take it to the next level. So that's about a quick demonstration how the custom resource works, right? So this is how the entire blueprint of the CloudFormation was. And you have this Lambda of custom resource. You define a custom resource, and in the service token, you provide the ARN for this Lambda and the IAM role to move this bucket data to another bucket. Now we'll also look into the demo layer stack, which will just take us like few minutes and then we'll wrap up the today's session. So demo stack, as I mentioned, this exactly, if I bring up 1 second, demo stack, open, 1 second. So this nested stack is the demo stack. So here, if you see, these are the 3 stacks, right? The IAM, EC2, and VPC. So these are the 3 stacks what I have, right? The same, the syntax, we don't have to really go deep dive into syntax. I mean, the format and everything remains the same. If you see, this is an important thing, which is the main controller, right? In the main controller, you will see that I've defined all the parameters, and under resource section, you will see the syntax varies. Instead of clearly calling out a particular resource like EC2, Lambda, I'm something called as AWS CloudFormation stack. And what I'm doing, the location of the stack, the other details like timeout, parameters, which is required for everything, for all the stack, right? So that when the CloudFormation is launching this, right, what CloudFormation will do, it will understand from the given syntax that this is my parent stack, this is a child stack which I need to execute. The child stack should be done in 20 minutes, otherwise it should get timeout. And these are the parameters via which I need to launch the child stack. That it's going to do for all VPC, IAM, EC2 in a given sequence. And at the end, you can print any output what you need in the parent control itself. Okay, so we'll launch this particular template here. Let me quickly check. So first, you need to ensure the only, I mean, in case of small difference in nested stack is, by default, nested stack will always look out for the template in S3 bucket. So you need to ensure that all the child templates are already present in the S3 location where you're defining, right? So here we are defining the S3 bucket name is my AWS session code. So there is a bucket. If I go back, my AWS session code, right? There is nothing as child template here, right? So what I have to do is first I will upload my all the child templates. So I'll go to the nested stack and I will upload all this child templates. And again, do ensure the child templates is uploaded under the nested stack. So you have to create this folder. Don't directly just upload it. You have to add a folder. 1 second. You have to create a folder here as a nested stack. And within that folder, then you need to upload it. So the paths which the template is looking for will match. Okay, so this how, if you see AWS my session within that nested stack, and within that you will see this template. The same what this particular format is needing, right? Now, the prerequisite done. I will take this URL. I'll go to the CloudFormation and launch a new stack. create new resources. This time I will give it from S3. So you will see by default, it will take it from S3. If I would have given a local, it would have uploaded to S3. Next, demo nested stack. From the availability zone, let's say I'm giving South 1B. Rest you can keep as it is the same, and you can click next. The same other remains the same other stuff, all the values and everything. And then we'll say create permission. And also you will see one more difference here. When I was launching one single template, you will only was asked, can I launch an IAM resource on behalf of you? Here you will also see there is one more, there is a new thing which is asking is capability to auto expand, which means CloudFormation asking you the permission, hey, can I go and launch one more stack on behalf of you along with IAM role? So we'll say yes, acknowledge both, and click on create. It will take next 2 to 3 minutes for the entire CloudFormation stack to get complete. In meantime, if you guys have any questions, please let me know. Hello. So yeah, as I was talking about, right, automatically when it came to this particular stack, it started launching IAM VPC stack, right? The concept will still remain the same of dependency graph. It start launching this two stack in parallel because there was no dependency between this both. Whereas the third stack, the EC2 stack, has a dependency, so it is not launching those two. So the dependency graph concept still remains the same even in the nested stack. Any questions here? So let's wait for a few minutes. If you guys don't have any question, let's wait for a few minutes. I'll keep the screen and then we can just resume once the stack is completed.
Sir,
Yeah.
sir, if I deploy an EC2 instance from the dashboard, EC2 dashboard, then stack is created.
When you do it without CloudFormation, no.
Okay.
Because you are manually launching it.
Yes.
Okay. Yeah.
Okay.
So the answer is no. Again, as you correctly reminded me one. You can launch an resource manually, right? Let's say you launch an EC2 instance manually, and now if you want to bring that resource under CloudFormation, import, right? That functionality do exist.
Okay. So if I manually deploy an EC2 and then I can upload it in the CloudFormation and get the template of it. And then
Yes.
if I want to deploy the same, then I can use that template.
Correct. Yes. Yep. Okay. Now, as you can see, this tag has also completed this and it's launching EC2 instance. Again, this tag of EC2 instance is exact the same. It will give you the same output and other stuff. There's nothing new. So let's wait for, I think, 2 minutes. That should be done. And again, if you have any questions, please feel free to ask the questions. So yeah, as we can see that all the stacks have been completed now. VPC, IAM and EC2, and the same, the demo nested stack is also completed. How we'll verify it? You'll go to the output. This is the output, right, of IP address. We'll take this, we hit, we'll get the instance ID, availability zone, and AMI. So that's about a quick demo what we have understood from this demo for this nested stack itself, right? And by default, you will see that this is how it launched in a given sequence of the same dependency. So please ensure that even nested stack do have dependency. It's not just within the resources. So that's what we have learned in today's session. And thank you. I'll quickly do a quick recap what we have learned. And then we'll open up for any questions what we have. Right? So we understood why you need cloud formations, what is exactly the cloud formation, how it can help you to automate the deployment of infrastructures. Expedia, the best example. You can have many other examples. Template, cloud formation, stack, those are the different ways. Then we understood in detail in technology perspective, like in technical depth, like what is the cloud formation, how cloud formation works, the concept of template, cloud formation, stack, the entire life cycle you can think of: create, evolve, and then finally have a deploy. The 9 different objects of template, structure, how exactly the template structure can look like each of those 9 objects. And again, do remember, resources is the mandatory requirement of the cloud formation. But again, it's highly advised and recommended you use the other objects to make your template reusable as well as mode friendly, so people can read, understand, and as well as can deploy across different regions and different accounts. Metadata, mapping, condition, we also in the demo itself how this work, transform. Then we understood how exactly stack, like the simple example which I gave, a zip file you can think of like a stack which has all the different resources, different type, different number of resources combined in a single unit. Then we looked into a simple demo of LAMP stack. We understood the custom resources as well as nested stack, and we have done a demonstration for both of them. And that's all what we have for today's session. I'll open up for any Q&As. If you have any questions, queries, please let me know.